Okay, well, can we do the arithmetic things we want? What about the successor function? Well, here is a string which probably looks at first like some gobbledygook, but this is indeed the successor function. What does that mean? It means that if you apply this string to any of these numeral strings, it will produce the next numeral. If I apply it to n, it will produce n plus 1. I'm going to leave this for you as a quiz because it's a good exercise for carrying out the machinery of the lambda calculus. Plug this in and do the substitutions and see what happens. Now, there are some things you should keep in mind. For one thing, we're going to get confused if we apply a string with a lambda f to another string with a lambda f. It's like we have two variables with the same name. So just as we would in programming, we can rename these variables if they're kind of local variables. So for instance, I could call n, instead of calling it lambda fx, f to the n of x, I can call it lambda gz of g to the n of z. So in the lambda calculus, we're always allowed to rename variables like that to avoid confusion. So there's our definition of nf again. And another thing you need to keep track of, which may take some work, this system is not associative. This is not like standard multiplication or addition. We really need to keep careful track of the parentheses. Okay, and indeed the default is if I have three symbols or three strings, A, B, C, well, the default is we put parentheses around the A, B and then tack C on after that. All right, so see if you can carry this out. It may be confusing the first time, but remember we already know what n does when we plug things into it. So plug it into s and see if you get n plus 1.